We're going to go over the WAVE study guide together. So I'll talk about some of your questions and then I'll talk about the answers. And then don't forget, if you can't keep up, just go ahead and pause the video and then you can make sure that you have the correct answers. So our first question is, what is a medium? And that's just the definition. A medium is a substance through which a wave can travel. Our second question asks you to write the definitions and draw write the definition and draw a transverse wave. So hopefully you got the definition, which is waves in which particles vibrate with an up and down motion. And here's a picture of a transverse wave. Of course, you didn't have to have that many waves, but there's a bunch of transverse waves there. All right, number 3, write the definition and draw a compressional wave, which is also sometimes called a longitudinal or a longitudinal wave. So the definition is waves in which particles vibrate back and forth along the path that the wave travels. And here's what a compressional wave could look like. Or you could have drawn a slinky or a spring. That would have been fine. Number 4 says draw a diagram of a transverse wave, label the amplitude, crest, trough, and resting point. So here's a transverse wave. Here is the amplitude, crest, trough, and resting point. I'm going to move this up a little bit. So our resting point is this line. Our amplitude is from the resting point to a crest or resting point to a trough, and the trough is at the very bottom, and a crest is at the very top of a wave. Number 5 said draw a diagram of a compressional wave. Label a compression and a rarefaction. So here is a compressional wave, and notice that the rarefactions are spread apart, the compressions are pressed together. Number 6, what's the relationship between energy and amplitude of a wave? The answer is the larger the wave amplitude, the more energy a wave has. An echo is the reflection of sound waves. Number 8, frequency. Draw a wave with high frequency and a wave with low frequency. So frequency is the number of waves produced in a given amount of time. So it's like how many waves pass a point in a certain amount of time. And we have a high frequency wave and a low frequency wave, assuming that they're happening in the same period of time. Okay, so clearly low frequency has a longer wavelength than a high frequency wave. All right, let's look at the second page together. Number 9, how does wavelength affect frequency? As the wavelength increases, the frequency decreases. Number 10, what's the difference between constructive and destructive interference? Constructive interference increases the energy of a wave, and destructive interference dissipates the wave energy. So constructive is like construction, it builds it, it increases the energy, it also increases the amplitude and the strength, okay? Destructive is when two waves come together and they kind of cancel each other out, okay? Number 11, what's the difference between reflection and refraction? Give an example of reflection and an example of refraction. So reflection happens when a wave strikes a barrier and bounces off. An example of that would be a mirror or an echo. Refraction is when a wave bends when entering another medium. Remember the pencil in the water? Okay. The difference between electromagnetic waves and mechanical waves for number 12. Electromagnetic waves do not need matter to carry energy, and mechanical waves need matter to carry energy. So electromagnetic waves can go through space where there's no like matter touching each other, like visible light rays, right? 4 examples of mechanical waves and 5 examples of electromagnetic waves for number 13. So mechanical waves are sound waves, ocean waves, seismic waves, guitar string waves, okay, anything that comes through the air. Electromagnetic waves would be radio waves, light waves, infrared waves, ultraviolet waves, X-rays, and gamma rays. Number 14, explain why sending waves to a boat floating on a pond would not move the boat. So here's the thing, waves, again, do not move matter, they move energy. So waves carry energy, not matter. The boat would move up and down, but not toward the shore. So that's the end of our review today. If you have questions or concerns, you need to let me know really soon. Send me an email, see me in class. Good luck on the test. I would suggest you practice on the Quizlet also, okay? All right, have a great day.